Hello and welcome to what I hope will be a series of old SMO reviews, and we are beginning with the SMO Junior 2019. Um, in case you are wondering why 2019, that's because we have gone all the way back to 2020. That's actually when I began doing these SMO videos, and then I kind of just didn't have time to go further back. So let's try to go a bit further back, starting with the 2019 round 1 paper from the SMO Junior. I'm not going to comment too much on the difficulty of many of these papers. The reason is twofold. The first is that, as we all know, it is quite subjective. The second is that as we go further back, the likelihood that you have seen some of these question ideas either in some of my other videos or from your school teachers or from your Olympiad teacher will just keep increasing, which means that if we're going very far back, very likely at least 20 to 30% of the questions you would find very familiar for one reason or another, even if you have not actually tried the paper before. I've included the paper, the PDF, in the description. You can attempt it before watching this, but that's the reason why I'm not going to comment on the difficulty. It wouldn't be really very fair anymore. However, what I can say is that the rules, at least for 2019, is still the same. 25 questions, 5 MCQ, 20 short answer, and 2.5 hours. So that much is still the same as it is as of now in 2025. Okay, so let's begin. I will split this paper up into more than one part because I think 2.5 hour videos are only interesting if you've just taken the SMO like 1 hour ago. Okay, so let's get started. Question 1, a classic. Which of the numbers has the largest value? This is always going to be something that has to appear in the multiple choice section because the answers are never going to be just nice small integers, otherwise you would just compare them. We can look at all of these, and the nice feature pretty much is that the bases are quite good, 2, 3, 4, 6, and 9. So I can compare them like 2 at a time. Okay? So for example, 2 to the power of 30 is 4 to the power of 15, which is more than 4 to the power of 14. So bye-bye to option C. Likewise, if I have 9 to the power of 10, I can compare it by changing it to 3. 3 to the 20 is more than 3 to the 19. So you can compare some of them like this. I can also compare these two among themselves because 2 to the power of 30, if I make the exponent the same, this is 8 to the power of 10. So this is less than 9 to the power of 10, so this is also out. Now, when we want to compare the last two, it is not going to be instantly possible to make their base the same or their exponent the same. So what I like to do for such comparisons is to use so-called question mark placeholder. Question mark placeholder is when you just have this and you do something to both sides. So for example, I can square root both sides. This. I can square root both sides again because square root of 9 is 3. At which point I can also divide both sides by 3 cubed. And of course, this is 8, this is 9. So since what I've done does not flip the order, that means that the one on the left is smaller than the one on the right. So this confirms that the correct answer to question 1 is E. Next up, number 2. Logic question. There have been a lot of logic questions, and because I am doing this not exactly in order, we may not fully see the trend, but very often they do have sort of like questions that come in pairs. So 2 consecutive years ask a similar sounding question for the logic one, but they are not exactly the same. So the introduction may be the same, but the situation can change. So the situation is that A said one of us is a truth teller. Exactly, one of us is a truth teller. And you know that options A, B, C, and D are the 4 potential outcomes. So you can really just check all of them to see whether they work. So if all of them fail, then something is wrong with the question. If one of them works, that's the answer. If more than one of them works, then there is not enough information to decide. Looking at this here, if they are both truth tellers, they would not have exactly one. So that's wrong. If they are both liars, then this may be true that A would say this untrue statement. So this is possible. If A is a truth teller and B is a liar, then A would also have said that there is exactly one truth teller. That already tells you the answer is E because both B and C are possible outcomes. The not enough information to decide is not necessarily just there as a placeholder, right? It's not because they need 5 options. It is quite possible to have many logic questions where there's not enough information to decide. So please don't assume that it is just there for show. Okay, number 3. You can see that Microsoft Word does not like my formatting. X minus 1 over x equals to 3. What is the value of 21 over 2 minus 3 over 6x squared plus 3 over 2x? First of all, that's weird. Like, why are you giving me 3 over 6, right? Let's just reduce that to 1/2. And let's then just put it like this. Okay, so x minus 1 over x equals to 3. If you are very new to Olympiads, you might think that now is the time for me to solve for x. That would not be wrong. We can just make it into a quadratic and solve the quadratic formula. Use the quadratic formula to solve it. It would not be very nice. Not wrong, but not very nice. Now, if you are more experienced with Olympiads, a different issue may happen because you may remember the very common idea of, oh, x minus 1 over x, I can always square it, which is not in itself mathematically wrong, but it does give us a 1 over x squared, which I really, really don't like. So the only reasonable thing to conclude is that neither solving for x nor squaring it is a good idea. But then how am I supposed to get x squared and x without squaring x? Well, the alternative is just to multiply both sides by x. Clear the fraction. Immediately you see that x squared equals to 3x plus 1 can just be substituted into here. The 3x will cancel, and so you have just 10 as your answer. Also take note that the first 3 questions answers are all E. Please also do not think of some of these meta guessing or the same answer will not appear more than once. I've been a student. We all think a little bit too hard about these when most likely the person setting the paper doesn't really care. So please don't assume it's wrong. Of course, you can check your answer, but there is nothing wrong with 3 consecutive E's. Okay, number 4. We're going to ignore Microsoft Word's formatting complaints. Let x, y, and z be positive integers satisfying these equations. Before we continue with the rest of the question, please do not skip over things like positive integers. It is very important. Most of the time, if you had 2 equations for 3 unknowns, we can't solve it. But when I tell you positive integers, then maybe we can. So you have to use the fact that they are whole numbers, and they're asking me for basically what are the possible values of x, add them up. positive integers have basically got two different aspects to it. The integer part means that it's nice, right? No roots, no fractions, no weird values. Positive means no zero and no negatives. So which one of those will apply to us first, we are not going to be sure immediately. But x plus y plus z equals to 2022 is very easy to satisfy. And I don't like that for my first step. I want to look for something that is difficult to satisfy. If we find something that is difficult to satisfy, then it increases the likelihood that I can immediately find, oh, x can only be this or that. So I'll look at the first one, because the first one looks a bit more weird, and weird is good if I can find out more concretely what makes it really weird. I think what I want to do here is to move the 2xy over to the other side, because I recognize, and you probably recognize, the x minus y squared. So this means that they are both 1 and 1 because they are whole numbers. Right? Two square numbers add up to 2. Gee, I wonder what they are. Except that you may then get a bit confused about why there are two solutions. And that's when you remember that, oh yeah, I still have the other equation, right? X plus y plus z is 2022. So that will help me to lock down z is equal to 1. Means that x plus y is 2021. But x minus y is 1. X minus y can also be minus 1. Right? Nobody said x or y are larger. They only said that x and y themselves are positive integers. X minus y can be negative, and minus 1 squared is still 1. So when I point 1 and 1, I'm referring to the square of x minus y is 1. Not that x minus y is only 1. It can be minus 1, and the other equation here is now going to give me that my xy can be 1, 0, 1, 1, 1, 0, 1, 0, or vice versa. Not too surprisingly, it means that if I were to add up the two solutions, I get back to 2021 again. So the answer is not E this time. How long has it been so far? It has been 12 minutes. For the SMO Junior, you are going to normally not run short of time to do your workings, right? Even when I'm talking and chatting kind of in an informal way, I'm not going to find myself short of time. It's more that you don't know what to do. So if you see a question like this and you can't figure out what to do, just skip it first, but just keep a mental note. I'm going to look at it again like 30 minutes later, 1 hour later, and maybe the idea will come. Now, question 5 is in one of my old videos on this channel, if you've seen it. I like this question as an example because this is the perfect way to answer those of you who ask the question very often. How do I know I'm supposed to do this particular step? Right? Now, for some of these here, it's like you do it because it kind of looks nice, right? So like I shift the 2xy over. For something, let's say like this, I do it because the alternatives don't work, and they clearly do not work. For something like number 5, we're given a pair of angles summing to 180 degrees. Please do not assume the diagram is to scale. Nobody said that, and it really isn't. The AC equals to 5. I'm not going to put it in because it doesn't really do too much. If you wanted to do some trigonometry, if you're familiar, you can use it, but that is not an expectation for SMO Junior. Now, when I have something like this, what I'm going to try is that I have to use the most annoying part of it, which is this. Well, they're not opposite angles, but two far away angles sum to 180 degrees. Now, when two far away angles sum up to 180 degrees, you really have a lot of potential options, because essentially if I were to just extend these out in any of these ways, it is possible that that is what you're supposed to do. You can potentially have that angle over there does something for us. But how do we know which one? Now, the answer is really that you don't know. You can try and see which one tells you anything about OD over OB. Like, for example, if you ask me, okay, what is the use of this red angles down here? I might say, okay, maybe I can make some similar triangles happen. So maybe I will be able to take this triangle ABD and make a similar copy of it, let's say, I don't know, down here maybe. So you can think of that and then you realize that, man, not good, because I don't know any of those sides. So if I say a similar triangle, then I'm just wasting my time. I can't do anything with that. Then what else is the use of those two being equal? I don't know. Then you say, okay, maybe I try a different one. Let's instead use the equal blue angles. I take this one, and now I plonk a copy down here. Now this is a little bit more promising. It's a little bit more promising because if there is this 3, 5, and 6 here, at least I will know all the lengths in here. This is just 2 times as big. So this here now is 10, and this here is 12. But then after that, what do you do to find OD over OB? I still don't know. Because after I put the similar triangle down, all I got is that this angle is equal to this angle, and this angle is equal to this angle, and I don't really know what to do with that. So scrap that and let's put it somewhere else. Now, this was better than the first attempt because at least, I still want to highlight that, at least that this length is 5. So I know it's 3 lengths. But when I put it there, it didn't do anything. So let's put it on the other side instead. Now, if I put it on the other side instead, meaning that I match these two, the ratio then becomes 4 over 3, right? So it's 4 over 3 times of the small one. 4 over 3 times of 6 is 8. What's the difference, you might ask? Well, the difference is that this time, I have got something better. I've got that this angle here is equal to this angle here, which means that I've got parallel lines. And if I've got parallel lines, then the ratio can just run over, or D over OB, runs over to here, 20 over 3 divided by 6. So that's 10 over 9, which is option D. I like these sorts of examples because it just is a reminder to us that when you read the solution in the book, and sometimes when you watch my videos, right, because I cannot tell you every possible wrong method, please do not come away from the videos or from the book thinking that these people are too smart for me. Also, don't come away from the videos or the book thinking that the explanation is not clear. There is no specific one-line explanation sometimes why do you do this. You just have to experiment. That's why you get 2.5 hours. That may not sound like a lot of time, but that's why you have 2.5 hours, even though some of the questions can be done in 2 minutes. Because there will be those where you need to experiment. And as I say in the explanation of question 4, please feel free to jump around. So if you don't see what to do, it's okay to come back like 1 hour later. It will improve the chances of you not getting tunnel vision, right? Because 1 hour later, you are likely to try a different method. Whereas if you keep staring at it for 10 minutes, 15, 20, 30 minutes, you are not going to change your mind. You'll be very stubbornly trying to make it work, and that's not a good thing. Okay, so that's up to question 5. I think we can continue on up to about question 9 or 10 in this video. I don't want to make the video length too long, as mentioned. Question 6. In the following diagram, all lines are straight. What's the value of the sum of those 10 marked angles? Couple of possible solutions here. The first possible solution is that you just start from the inner pentagon. Now, the angle sum in your pentagon, 5 minus 2 times 180 is 540. Then that will run to the vertically opposite angles. And once you run to the vertically opposite angles that sum to 540 degrees, then we are in 5 triangles. And so it will be back to 5 times 180 degrees minus 540, which is back to 360 degrees. So that is already the answer. An alternative way of looking at it is just to use the exterior angles instead, because A plus B would be here, C plus D, E plus F, G plus H, I plus J. And it is known that the sum of the exterior angles of any nice looking polygon, doesn't matter whether it has 3, 4, 5 or 100 sides, this is going to always be 360 degrees, precisely for the same reason as we've written here. You take 5 minus 2 times 180, and then you take 5 times 180 and subtract it again. So in fact, this question is just illustrating the fact that the sum is always 360 degrees. Question 7. Let x be a positive integer. Suppose that the highest common factor of x and 80 is 40, and the highest common factor of x and 252 is, is 12. What is the minimum value of x? When I encounter a question like this, it's not just about finding x, it's also minimum value of x that you want to pay attention to, because it means that you're not supposed to find x because potentially there is more than one value of x. So if there's more than one value of x, I just need to find the smallest one. So what do I need to make sure my x satisfies? Then the bare minimum is my target. So when I read this, I say highest common factor of x and 80 is 40. That means that 40 is still a factor of x. Highest common factor of x and 252 is 12. 12 is a factor of x. So it means that 12 and 40 are both factors of x. That's the main condition that I can see. So I can just try x to be their LCM. And the LCM of 12 and 40 is quite obviously 120. So I just check that, and it works. So that's the answer. He asked me for the minimum, so I try the smallest potential answer. If it works, then it works. I don't need to worry about all other possibilities. Incidentally, 80 and 252 are mostly just there for show. It is only that you still have to check it works, right? If I were to put some other weird number, let's say I put the highest common factor of x and 120 is 12, then this is not going to work anymore. So 80 and 252 are just the job of the question setter to make the final answer work, but it is not actually part of your solution. Number 8, m and n are positive integers where 100m over n is a perfect cube greater than 1. What is the minimum value of m plus n? One more instance of minimum value. The issue with minimum value sometimes is that in some cases it is self-evident that I need it to be a factor. So I need 40 and 12 to be a factor here, so therefore the smallest potential candidate is 120. So I know for sure there isn't anything smaller, right? I could not have missed anything. But sometimes when you do something, you don't really have a good explanation. So you look at 100m over n, and first instinct is that, oh, what's a cube? I know a cube. 1000 is a cube. Right, that's the most obvious cube number that's related to it. So I let m equals to 10 and n equals to 1. And that gives me m plus n equals to 11. And then you are not entirely sure whether this is correct, right? So how do I know whether this is correct? You do not need to write a justification for round 1. That is true. However, checking your answer for a question like this is essentially the same as trying to find a good reason. And if you cannot think of a reason, there is a good chance that maybe you can do better. So let's think a bit more about this. A perfect cube is essentially that when you take the prime factorization, all of the powers are multiples of 3. So 100, which is 10 squared, is 2 squared times 5 squared. 2 and 2 are not multiples of 3. Now, that means that you can lift them up to 2 cubed and 5 cubed. That's what m equals to 10 and n equals to 1 does. However, you can also push it down to 2 to the 0 and 5 to the 0, which is 1. In other words, you can get rid of it. Picking both of these corresponds to this choice. If you pick both of these, this corresponds to m equals to 1 and n equals to 2 squared times 5 squared. Divide both, and that's clearly worse. Anyway, it doesn't work because it said greater than 1. So this is both invalid and lousy as a choice anyway. However, when we reason it out more carefully, we will realize that there is also the choice of taking one of each. So if I took this choice, it means divide by 2 squared and multiply by 5. That's actually better. If I took this choice, it means multiply by 2 and divide by 5 squared. Now that's not so good. So we have considered all the possibilities now. By doing that, we are sure that our minimum is actually correct. It is 9. But do remember that we are not just finding a value, we are finding the minimum. This is the point where we just remind everyone this is an Olympiad, right? There are sometimes double blumps where the answer is just the most obvious thing in front of you. But very often, if it seems too obvious, it means you're not thinking the whole thing through as you're meant to. It's a trap, right? 10-1 is really juicy and enticing. So all the more it should make you think, is this a trap? Like, how can it be that easy? Since we're on the first part of the paper, it's also worth mentioning that the multiple choice from question 1 to 5 are not the 5 easiest questions in the paper, right? Clearly question 5 is not that obvious. But it is usually true that questions 1, 2, 3 are not going to be impossibly hard, as well as when you go to the start of the short answer section, 6, 7, 8 are also not supposed to be very hard. That is true. But not very hard doesn't mean that you can just literally guess M is 10 and is 1. That is maybe being a bit too optimistic. Another one, largest possible. Now I'm going to just contradict what I just said, because when I look at the largest possible two-digit positive integer that is 18 more than the product of its digits, I'm just going to notice that 99 works. I said about double bluff, right? It can happen. But unlike question 8, there is no bigger two-digit number than 99. So you do not need to think about that. Whereas for this, you should say, is it that easy? But for this one, when you get 99, you don't have to ask yourself, is it that easy? Because 99 has to be correct. What bigger two-digit number are you possibly going to give me? This is the dynamic of the largest possible and the smallest possible and the maximum and minimum kind of questions. It may not go the way that you think they do. Okay, let's end this on question 10. So I'll end the first part on question 10. This is interesting because now when I read this question, it sounds like a PSLE problem first, and then you realize, how can there be enough information here? And then you realize that the question finally did not say minimum or maximum, it just asked you how many. That's actually a bit of a surprise. It means I can actually figure that out. So let's look at all the statements. $77 for 25 gifts and 2 for $5. There will be lots of ways to combine them, I'm sure. I'm not going to list them out, but I know there are lots of ways. But then it's not really 25 gifts and 77 because it bought more than 3 gifts. So that means that at least 4 of each. So let's just calculate that part first, right? So 4 times 3, 12 gifts, and 2, 4, 5, $44 was spent. So you're left with 13 gifts at $33. But there are no more restrictions here. I'm a little bit surprised, of course, that this is enough at one glance, since it's like, but there's so many combinations of 2, 4, and 5. However, this is now quite a small budget, right? Because this one here, 25 gifts, $77, I've got more than $3 per gift. Here, 13 gifts at $33 is less than $3 a gift, and $4 and $5 are both quite expensive. Which means that I can actually work that out, right? If they were all $2 gifts, then it would be $26. There are an extra $7. This is an extra $2 to upgrade a gift. This is an extra $3 to upgrade a gift. So 7 must have come from 2, 2, and 3 as your top up. Which means that you replaced 3 of these. There were 10 $2, sorry, 10 $2 gifts. You replaced 2 of them with $4 gifts. And you replaced one of them with a $5 gift. Sorry, that looked like $14. So 10 $2 gifts, 2 $4 gifts, and 1 $5 gift. So that means the answer is 10. And if you were just getting ready to type a comment in the comment section, then good for you, because the answer is not 10. The answer is 14 because you have 4 gifts in the original, at least 4 of each. That still counts. So don't forget to read the question again. If you're the sort that makes a lot of careless mistakes, you don't get method marks for the SMO. So remind yourself, read the question again if you always mess up, otherwise all your effort is gone to waste. So your answer is not 10, your answer is 10 plus 4 equals to 40. Okay, this is where we'll stop for part 1. You will see also that we've taken about 35 minutes for 10 questions. A very healthy rate since we have 2.5 hours technically for 25 questions. So it should not be too stressful. I have just realized that my background is blocking the final answer. If it's blocked anything in the previous parts of the video, I apologize. I don't think I've written too much in the bottom right corner, so it should mostly be fine. I'll upload parts 2 and 3 pretty soon. If you have anything else to ask, as usual, please do so in the comment section below, and see you again soon.